What's up, guys? This video is about 5.1, using transformations to graph quadratic functions. In this video, we're going to show you how you're going to take a parabola and you're going to shift it left and right, you're going to shift it up and down, you're going to stretch, you're going to compress, you're going to do some yoga, you're going to flip it upside down, move it all around. Okay. Do you guys remember when we did h comma k with absolute values? No, Mr. Blair, not those again. Why is it negative? Why is it not there? Yeah, we're going to bring back h comma k like we did before with absolute values. So just to give you a little refresher on that, if we had something like this function, f of x equals the absolute value of x minus 2 plus 3, well, the graph of an absolute value should always look like a V or an upside down V, and you can move it left and right. Okay, and then you move it up and down, left and right, all that good stuff. So the center of this guy is going to be h comma k, and where this function is written like this, a times the absolute value of x minus h plus k. So what is the center of this guy here? Well, it is 2 comma 3. But Mr. Blair, why isn't it negative? Remember, we talked about that. Go back to that and find that out. So to graph this guy, we would have something like this: 1, 2, 1, 2, 3, and it's going to go up 1 over 1, and it's going to be an absolute value like that. Okay, that's a review. Now for 5.1, we're going to talk about parabolas, and in this, we're going to get function of x is equal to a times the quantity of x minus h all squared plus k. All right, so again, what do you think h does? It moves x values, so x-axis. So it's going to move left and right, and k is going to move y values, so the y-axis. So it's going to move up or down. It's going to shift your parabola. So the parent function is f of x equals x squared, and remember that just looks like this graph here. Wow, that was a beautiful graph. Good job, Mr. Blair. So that's what this looks like. If there was an a out in front of it, like a number, it would move it by stretching or compressing. If a is negative, what does that do to the graph? Well, it would actually take this graph and it would flip it upside down. So it would flip it upside down beneath the x-axis. And then h comma k, well, h is going to shift my graph left and right, and k is going to shift my graph up and down. So it's the exact same concept as we have done before with absolute values, and now just this time we are going to do it with parabolas. Okay? So let's answer a couple questions like this. So this is something that I took off the online book, and name. Let's put your name there. Let's go with Papa Blair. That's me, right? And I'll spell it weird like that. Today's date in class, blah, blah, blah. Graph the function by using a table. So if we plug in an x value into my function, we should get an x comma y value. So if I plug in this here, I'm going to get f of negative 2. So my function, by the way, is x squared plus 2x minus 1. What does this look like? Well, this value here, x squared, you see that there are no other x to the seconds or thirds or fourths or to the half or whatever like that. This is going to be a parabola. Okay, so I know it's going to look like a parabola. I don't know exactly what it's going to look like, but it will definitely be a parabola. So let's look at it. F of negative 2 is equal to negative 2 squared plus 2 times negative 2 minus 1. Negative 2 squared is 4, plus 2 times negative 2 is going to be minus 4. So 4 minus 4, that's 0, minus 1. So this is going to become negative 2 comma, well, what is f of negative 2? It is negative 1. So negative 2, negative 1. And then here we go for this next one, f of negative 1. I was double checking my algebra to make sure I did that right. This is going to become negative 1 squared plus 2 times negative 1 all minus 1. Negative 1 squared is positive 1. 2 times negative 1 is negative 2, so positive 1, so that becomes negative 1, so that's negative 2. So it's going to be negative 1, negative 2. And that's over here. Negative 1, negative 2. And as we continue, f of 0 is going to become 0 squared plus 2 times 0 minus 1, so this is going to become 0, comma, negative 1, and that's pretty easy. Okay, and then f of 1 is going to equal 1 squared plus 2 times 1 minus 1. 1 squared is 1, plus 2 times 1 is 3, minus 1 is 2. So 1 comma 2, 1 comma 2 like that. And f of 2 is equal to 2 squared plus 2 times 2 minus 1. 4 plus 4 is 8, minus 1 is going to be 7. So 2 comma 7. Two comma 7. And it looks like we have this shape here. And it's symmetrical. It looks like about this mark right here. It looks like it's symmetric at x equals negative 1. So this is the idea on one of the tasks. You're going to be doing something like so. Okay. Now just to show you guys something, this next problem says using the graph of f of x equals x squared as a guide, describe the transformations and then graph each function, label each function on the graph. So you're going to put all three of these problems onto this here. Well, let's look back at some notes for a second. Oh, messed up the camera. Well, let's do this here just to give it a little fresh piece of paper. We have h of x is equal to x minus 2 all squared plus 2. Okay, well, let's think about this. What is h comma k? What is the center? Well, the center is 2 comma 2, right? Now, is there an a value right here? Is there an a? That's the real question you should be thinking about, because a, remember, stretches or compresses, or it's going to reflect it downwards, upside down. Well, a is equaling 1 here, so there's not going to do any stretching or compressing. So if we go over 2 comma 2, my function will remain like every other standard parabola. And that is my function, h of x, right there. Okay, let's go back to this. So use the graph of f of x equals x squared as a guide. Describe the transformations, and then graph each function. So to describe this, I might say shift right 2, up 2, right? Right 2, up 2, bam. There's my graph. And we're going to go up here through that, and up there through there. Now this next one is interesting. It says h of x equals negative 3 times, excuse me, negative 3 times x all squared. So you got to think about what this is going to actually do. Well, this negative sign is going to reflect downwards. And then this 3 here is going to be doing some stretching. Stretch by 3. Okay. Now in the book in 5.1 you'll see some examples, but let's look at this one real fast, and maybe we'll use some points and plug it in. H of x equals negative 3x squared. Now notice the negative is outside of the actual thing being squared. So if I plugged in a point such as 0, I would get 0. Do you guys agree with that? But if I plugged in a point 1 here, well, 1 times 3 is 3. 3 squared is 9. And then if I take the negative of that, that becomes negative 9. So on my graph over here, I'm going to get 0, 0, and then 1 comma 9. And so as you can tell, I have stretched this graph out. Whoa. 1 comma negative 9. Oopsie daisy. That point shouldn't be there. 1 comma negative 9. I knew it should be going upside down. That's why I knew something was wrong. And so it's going to look like this. We stretched it way out. Okay. And if you plug in negative 1, you'll see that we get the same value. So let's check this out. If I plug in negative 1, I get 3 times negative 1 is negative 3. Negative 3 squared is positive 9. Negative of positive 9 is also negative 9. And so that's why I noticed up here, I started making a mistake. I was like, wait a minute, I know that this graph here has a negative in it. So it should be going downwards, and so as I noticed that, hey, this point shouldn't be way up there, so we flipped it upside down. Okay, you would do the same thing here with this half. Try that, pause the video, try doing this with the 1/2 x squared and see what you would do. I'm going to label this one here. It says label each function on the graph. Here's h of x. Here's the other h of x. This one is negative 3x all squared. And this one is x minus 2 all squared plus 2. Okay, pause the video, try to do this problem number 4, and then after this I'm going to let you guys go and you can do the homework. Alright, since you've paused it, you should be getting something like this. You should have h of x equals 1/2 x all squared. So, well, you know it's going to be at 0, 0. Okay, there's no h comma k here. There's no h comma k, but you do know that there is this a value here. So if I plug in 1 times 1/2 is a half. A half all squared is 1/4. And if I plug in -1, I will get the same value. You guys see that? So since we have that, well, what's going to happen to my graph? Well, it's going to compress or stretch by 1/2. And now let's try to plot that. We have 0, 0. That was one of our points. And then 1, 1/4. 1, 1/4. -1, 1/4. And it'll go way out like this. Okay. And that's it. The other problems on here, I don't worry about you guys doing. What I'd like you to do is to do the 5.1 tasks. There's 2 of them for class, whenever you guys have this class day. And there's 5.1 homework. You should be working on those as well. If you guys have questions, you guys can send me an email. If I'm not here, you guys know it's because I might be Papa Blair. So I'll see you guys soon. Bye.